Hi everyone, welcome to lecture 13. In this lecture, I'm talking about images, how to work with images in Python, how to open and access images and do a little bit of manipulation. Now, before we get started with working on images using Spider, I just wanted to make sure that we have this library called Pillow installed before we begin. If you have Anaconda installed on your machines, you should have by default Pillow installed. But if not, if you downloaded Miniconda, you should go to your Anaconda prompt and either do pip install or conda install pillow. One thing that I would prefer is conda install pillow. Just go and type this in your Anaconda prompt window if you install Miniconda, and once it gets installed, you're ready to work with pillow. Now, what is pillow? It's a series of modules that's also called a library. Now we are familiar with what modules are. So series of modules put together and it created this library called pillow. And using this library, I can work with images. I can import the image type in Python. Now we'll see what exactly I'm talking about. I have a series of existing examples that we'll go through. So let's go to Spider first. The first thing is to import pillow. I could also just simply say import PIL, that's the short for pillow, and I should be all started. I should be all fine basically. I can say from PIL import image. Now this line means that I'm trying to import only the module image from PIL. So either one, whichever works for you, is okay. So let's do this one also, and here we don't get any error. That means we are good to get started with images. Now before I begin with the second line, explaining the second line, I just want to make sure that we know what our working directory is. If you don't know and you're working with Spider, you should go and check here. This is your working directory. You can even go and change this, right? So this is where all your programs are running right now. Now I have a couple of images saved exactly at this location in my computer. You should do the same. And obviously we're familiar with pictures, right? And we know that pictures have these kind of extensions, .jpg, .jpeg, and so on. So go and save the image that you want to read in your Python program exactly here in your computer, right? Once you're done with that, save file in your working directory. This is important. Now, if not, wherever your file is saved, you have to copy and paste the path here. So either go and get the path of the file wherever it's saved, or save the image in the working directory, whichever works better for you. For me, I have this bloom.jpg saved exactly at this location, so I can go and access it. Now the way I'm trying to access it is I'm giving it a variable called file name. So this, you know, is the assignment operator, right? So I'm assigning this bloom.jpg to this file name. Let me do that. Now file name is a variable that has this file now, right? The command to open this file is image.open. The moment you go and after you've imported image, you go and type image dot, you'll get these series of methods that we've talked about earlier, right? And then you can call the method open. Now here I'm calling image.open, and instead you can directly use this name here instead of the file name, but file name variable already has bloom.jpg, so I'm just calling that. That's the argument here, right? And then this open is saved in a variable called im. I'll show you why, because if I just copy this and run this alone, right, it directly goes and opens this for me, which is fine, and this is the image that I'm trying to access. But I might want to do other things with this image as well, right? So I'm trying to open this file and save it in a variable called im, and then go from there, right? Another thing is that if I do not run it directly in the interpreter, and if I just have this command in some file, it might not even open it. So the better idea is to go and save it in this variable called im, and then go and say im.show. Now this is the proper command to actually show the image, to actually open it outside of Python, just like as a picture, right? Because that's what we need. So we'll say im.show. Im is my variable where my open is saved, right? Where my file is exactly saved in Python. Let me do that now. Okay, so we did not create IM yet. Let me do that. Now do IM.show. Now this is what I was talking about, right? I do not want that to be opened here somewhere inside. In fact, I want it to be opened as a picture in my computer, right? I can open that using this command. Now there are certain attributes to a picture, and we'll go back to our slides and then come back here again. Those attributes are the size of the image, the format in which it's saved, and so on. So I'll begin with talking about the size of the image, the way this size is saved in my computer. Any image is divided into this small grid, any picture, right? And this is how my x-axis and y-axis are defined in my picture. And these small squares of unit size, these are called, as I said, pixels. And each pixel has a location relative to this origin here, right? This is my origin because I have these boxes starting from 0 up to 5, and this is from 0 up to 4, right? Or in fact, it should be counting. So this box here, this entire box on the left topmost corner is 0, 0, right? So each box, which is like a unit size box, which is also called a pixel, has some dimension, right? It has an x value and a y value, and that x and y value determines how many pixels I have, and this is called, the x is the width of my picture and y is the height of my picture. This is how I represent my picture in my Python working environment. And this is an example to show this is a real picture, and the way Python is going to read it is that it will read it in certain like what is the width and the height of my picture, and then the way it is going to read it is again convert it into pixels, and the finer the pixels are, the better the quality of the image is, right? And this is the way to represent a picture in Python. The other thing is the color of the picture that, or the image that we are using. Pixel values in an image can be colored or grayscale. A colored image is represented by an RGB. So RGB is nothing but a 3 tuple. It tells us like what all colors are there in this image, and like what is the amount of that color. And if it's an L if the value of the color is L, that means it's a grayscale. So these things might not be super clear right now, but they will be clear when we go back into Python and see what all these means. Just to quickly show you the RGB, the basic colors that are there. R stands for red, G for green, B for blue. These are the values, and they exist in the form of a tuple. We know what a tuple is, right? So black, completely black image would have like red 0, green 0, blue 0. A completely red image would have 255, that's the highest they can go, and 0 green, 0 blue, because it's a red picture, and so on. And a light gray is 122, which is like midway between 0 and white, because white is 255 for all three colored values, right? So this is the way we represent pictures or images in Python. Let's go back and check in Spider, how do we use them, right? So now this is the information or the attribute that are related. So all these are attributes that are related to my image IM, right? So let me go and print these attributes. The way I'll get these attributes is im.format is going to tell you the format of your picture. The format of my picture in this case I already know is .jpg, so that's the thing that it should return. Size is the pixel values that I'm going to get, and mode is the color, like what values of RGB are there in my picture. Let's see what the values are. Okay, so instead of like printing all of this, I'm interested in just these things here. So I shouldn't have printed like everything. Let me just print this part because I don't want to print IM itself, right? It's giving me the location and all of that, which I'm not interested in. So I'm interested in the format. I know this is a JPEG image. Then im.size, the pixel size, this is the x value, this is the y, also this is the width, or this is the height, right? So this is my pixel value, and this is a colored picture, so it's an RGB. It's type RGB, right? So this is telling you the attributes of your picture. Now we can do more manipulation with pictures. For example, we can crop these pictures. Let me do that. The way we can do that is the name of the variable that has your picture. Remember, this was IM because I saved my image dot open in IM, and I can go and crop it. The way cropping works is you have to tell where the cropping should start and where, so this is width and height where it should start, and this is width, height where it should stop. This usually is the left hand side corner and this is the right hand side corner. And make sure that when you're using some image, it has these dimensions, right? My image has 1024 and 768, and so obviously 600 and 600 are less than these two values, so I can go and crop it, right? Let me go and do that. Now I cropped it, I did not get an output. Why? Because I saved my output in im2. Crop itself will not produce an output, so we will have to go and say im2.show. So this is the way I cropped my picture, right? The starting point was 0, 0, so obviously we know the left top side is my starting point, and then this was my ending point because I said 600 here and 600 here, so both are there, right? Now I can rotate my image. So IM, remember, is my original flower image. Let me go and rotate it by 180 degrees. This goes up to 360, so you can rotate up to that. And then again save it in a variable, remember. And then just say show. My image is rotated, right? It's 180 degrees rotated. It wasn't like this before. Similarly, I can use im.convert to convert my image to grayscale. Let me just out of the screen because we just want to focus on one thing at a time. I created this variable gray_im in which I'm saving the outcome of .convert. .convert converts basically from your RGB format to L, which is grayscale, remember? So I can convert my images to black and white. Let me do that. As you can see, this is converted to grayscale. Okay, other manipulations that we can do with our image is resizing them, right? So what I want to do is shrink my image to this size. This is called resizing, right? And my image is gray_im. So this, I'm trying to scale my gray image, not the original image. And then I'm saving it in the scaled thing, and then I'm going to find the attributes of that scaled value, right? Let me do that also. Yeah, so here I get the attributes. We haven't saved our scaled value, our grayscale, this gray_im anywhere, which is why I get a none. It does not know the extension of that, right? So which is why I get a none here. Scale.format gives a none because I haven't saved it yet, right? The scaled.size will give 128 and 128. Why? Because I scaled it to that size, right? So that's the size. And then the mode gives me the color. It's grayscale obviously because I did that. And then I already saw how it looks, or maybe we haven't seen this one. The scaled, yeah, it became really small. It became really small, right? Okay, now I can save the scaled somewhere, and that's done by using the name of the variable that you use to save your picture in, .save, and then simply give any file name you like to give here. I'm saying file name plus underscore scale.jpg, because remember this was my initial file, right? File name has the name bloom.jpg, right? The way it will be saved now would be bloom underscore scaled.jpg. So you should go and try it. When I do that, it's saved under this location. It gets saved under this location. That's how you resize images. Okay, there is another example that I have in which I'm showing you how you can do copy and pasting with images. So again, you don't have to run this again. We already did that. I have another picture called sheep.jfif. I have saved it in the same location as given here, which is my working directory. So let me go and read it, right? So these are the steps that we already know. Let's quickly see. So this is a sheep's image. What I want to do is I want to create another image that will be of double the size of this image and will have this picture twice. So basically I need a blank image, a vertical blank image, in which I'll have this and another copy of this pasted on it. So here we'll see how we can copy and paste, right? Now the first thing I need to find out is what's the size of this image, because basically I'll be creating an empty black colored image because I don't need color on that one, right? Twice the size of this one, and then paste two images on it, right? So let me see the size. It's 500 and 375. So the width is fine because I'm trying to paste them vertically, one over the other, but I have to create an image such that it's twice the height of this, 375 times 2. The command for that is image.new, and then the arguments are what size. Size is the second argument, and what mode do you want. So I want an RGB. That's the general way of specifying the new image, although it will create a blank black colored image, but I'm just saying that it needs to be RGB because I will be pasting colored images on it, right? So let me go and save that in im5, and then see what im5 has, right? I created this empty image. Whenever I'm creating a blank image, it has to be done by saying image.new. Image is the module that has images, right, in Python. Now this is the blank image that I created. Now remember the sheep image, the way I want to present that is paste the first one here, and again the same sheep image at the bottom, like one over the other. For that, the command is called im.paste. As you can see, I'm not assigning .paste to any other variable, just like I've been doing for other cases, right? I've been creating new variables and assigning those, because paste works in a different way. It 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 actually changes the input. The rest of the commands that we've been using until now did not change the input. They do not change the original image. But this dot paste will change the original image. So I do not need to assign it to anything. Okay. So let's go and do that. Paste takes like, what do you want to paste? Where do you want to start pasting? So I want to paste IM4 because that's my sheep image. And I want to start from 0, 0. So this is my width, this is my height, right? At the top. Let me do that. And then see what happened to our IM5, right? This image got pasted here. Fine. Now I need to paste this image again here. Where do I need to start? Obviously here, right? Here the width hasn't even started, so the value for width is 0, but the value for height is 375, right? That was the original value, and I want to just start at 380. Just like, let's leave some space in between. You can start at 375 as well. There might be a little bit of overlapping, I don't know. Let's see. Yeah, you can see there's a small gap in between, right? You could have filled that gap, that's also fine. But that's how you can paste images, right? But just remember, one thing that I would want you to remember is know the difference between dot paste and the rest of the image commands that we've been using. Okay, one last is to show you what cropping can do, and this is an optional exercise just to show you that we can do cropping and pasting all together and how that works. I have this image. Let me show you this image itself. This is my Lego image. You know that the size of the image, that's the pixels, the width and the height are saved in tuple form, right? And in tuples we can do multiple assignment. So I'm creating these two variables, w and h, because I know that image.size is going to return a tuple, right? Width and height. Now I can do manipulation with this width and height such that I'm creating 3 columns of this image and then kind of haphazardly pasting one like one earlier and the other later and so on. So I'm creating part 1 that I'm cropping, and remember what crop takes, 4 arguments: where to start, width and height, where to end, width and height. Now I'm trying to do 3 cuts or 3 crops. So I'm starting at 0, 0 and then ending at like 1/3 of the width, and height stays the same, right? And then 2/3 of the width. And notice the integer division, because I don't want to get into floating points here, because floating points will not work with crop. Okay, so I created part 1, part 2, part 3, and then let me paste them. But before pasting, just like we did with the sheep image, with this one also I'll create a new blank image. Again, we know that this is the blank image, but the size of the image depends on my current image, right? And so the size is the same as W and H. Now I will just haphazardly paste part 3 first, and then part 1, and then part 2, because this is just for fun. Let's see what happens. You must try this yourself with other images as well. Let's see what happens to our Lego image. So as you can see, these were haphazardly pasted. Part 2, this is the last part, that is first now. And then this was in the middle, this is moved here, and this was somewhere else. And so we created a new image completely, right? And what's this im6.show? I think this was the original image, just to make things clear. Okay, so with this, I end this lecture. In the next lecture, we'll talk about lists. Thank you.